So for review homework part 3, I want you to tackle a problem using an object-oriented approach. Now I want to show you an example of the rock, paper, scissors game. This is actually an example that I did as part of my Java 1 class. So there's a video where I actually create this program. So here are the instructions from the book. It explains the rock, paper, scissors game. It tells you it wants you to track the wins, losses, and ties, and it wants you to play the computer. It's important to remember that I didn't take an object-oriented approach. There's two things going on here. In this program, the same file is managing the game and also managing the interaction with the user. Those are two separate things, and for better software reuse, it's always better to approach this in an object-oriented way to where the game is separated away from the user interface. That way, if I ever decide to take another user interface like a GUI, I still have all the logic for the game in a separate class. However, I didn't take the object-oriented approach when I created this game. I created variables for rock, paper, scissors. I created a scanner class. I created variables to hold the wins, the losses, and ties. I created variables to hold the user's entry and the computer's entry. And then I have a loop control variable, which is done. So done is controlling my while loop. I present the user with the menu. I tell him enter 1 for rock, 2 for paper, 3 for scissors. Now above, rock was 0, paper was 1, and scissors was 2, but this is different. The reason why I took this approach is because it's more natural for somebody to start numbers with a 1. So for me, it seemed like the interface would be a little better if rock was 1, paper was 2, and scissors was 3, and then I told the user enter 0 to quit. I store the user's value, then I subtract the value by 1. I do this so they can correlate to the values that I have here for rock, paper, scissors, but this also means that if they enter a 0 to quit, it's really going to be a -1. Then I have a loop right here that's going to check to make sure that what the user entered is not outside of -1 and 2. If it is, it's going to say invalid choice and prompt the user again. This is a loop, so it's going to keep going until the user enters a correct value. Again, I'm subtracting the value by 1. So what I'm doing here is I'm setting done equal to the equality check of what the user entered to -1. So if it does equal -1, this will return true. If it doesn't, it would be false. So if we're not done, meaning the user doesn't want to quit, then I print out the user's choice. I have this method here that I created, getItem, where I pass in the choice, and then I generate the computer's guess. And then I do my comparison to determine if it's a win, a loss, or a tie. So once the user wants to leave, once he breaks out of the while loop, I'm going to tell him game over, give him his win total, his loss total, and his ties. And here's the getItem method. It's going to return a string. It takes in an integer, and it's going to take that integer and determine if it's a rock, paper, or scissors. If it's anything that is not equal to rock, paper, scissors, which is 0, 1, and 2, then it's just going to return a blank string. However, we should have written our logic to where this choice will never happen. It would always be one of these choices. So before I rewrite rock, paper, scissors using an object-oriented approach, I wanted to explain what I'm asking for when I say separate the game logic from the user interface. Here's the user. He's going to use a computer. He's going to select our rock, paper, scissors game. The computer is going to pull up the rock, paper, scissors game. It's going to launch the program. And now our program is interacting with the user, reading in the feedback that he types in into the computer. So here's our rock, paper, scissors game right here. That is the program that's running. Now, when this program runs, inside of this actual program, I have one file. The rock, paper, scissors game, RPS, I abbreviated it, is managing two things. It's managing the game and it's managing the interface with the user. So this is actually the portion that is displaying information to the user and reading things back in from the computer. And then we have a loop in here with some logic that is actually determining what game info to set, like the wins, the losses, the ties, the logic to determine if the computer won or the user won. There's all this data for the game that this one file is managing. And then the interface is basically our command prompt that the user interacts with. We'll say this is our command prompt. So this is the interface that we're presenting to the user. So this is what he sees on his screen. Now, since the interface and the game are in one file, they're tightly coupled. Meaning if we ever wanted to change this to be a graphical user interface, so we're not presenting the interface as a command prompt, all the game logic and data is intertwined into this one file. So this is a poor software reuse. So the correct way to write this is to have a separate file for the game logic and a separate file for the interface. So the interface has to instantiate an object of the game in order to use it. So if we ever decide in the future to use a different interface, let's just say we learn about GUIs, so we want to use a GUI for this interface instead of command prompt, we can create a new file specifically for the graphical user interface. So now this GUI interface can use the game, and I don't have to rewrite any of the game logic because it's its own separate entity. This graphical user interface can just instantiate an instance of the game and use the rock, paper, scissors game. So knowing what we know now, I'm going to go ahead and take an object-oriented approach to the rock, paper, scissors game. I have two classes, one called rock, paper, scissors. This is going to be my interface to the user. This is going to have the scanner class, and it's going to have the loop in the menu, and it's basically going to prompt the user for an entry and send that information off to the rock, paper, scissors game. So it's going to actually instantiate an object of the rock, paper, scissors game. The rock, paper, scissors game is going to be my blueprint for the game. It's going to have all the data we need. It's going to have the logic we need to check which item won or if the item's tied. So to start this off, what I'm going to do is I'm just going to copy and paste what I did for the previous example. So I copied and pasted what I did for the previous example. So what I'm going to do is I'm going to cut out what I feel like is the game logic, like these constants here. This should actually go into the rock, paper, scissors game. And the wins, the losses, the ties, that should go in the rock, paper, scissors game. So I've moved those variables over. Now you can see inside of my driver class, I do have some errors here, and that's because I took out the game logic. Another thing I want to remove is I want to move this method over to the rock, paper, scissors game. I'm going to keep this method static because I feel like it's not really related to an instance. It's actually related to the entire class. This is basically going to determine what integer value correlates to the rock, the paper, and the scissors. So I'm going to leave it as is. So the next thing we want to do is we want getters for the wins, the losses, and ties. Now this is where you have to think, okay? So this is kind of important. I'm making a game that is going to play rock, paper, scissors. Now, I don't want to just tie this down to playing rock, paper, scissors with a computer. This is going to manage rock, paper, scissors between two people. So if that's the case, then the wins, the losses, and the ties are going to be applicable to who, right? So I'm always going to say player 1. These values are going to be applicable to player 1. Now, if we want to get the player 2 wins, we can just get the player 1 losses. If we want to get the player 2 losses, we can just get the player 1 wins. So I know that's kind of confusing, but you kind of have to think about these things. So the first thing I'm going to do, I'm going to make getters for wins, losses, and ties. I'm not going to make a setter because this game is going to set the values of win, losses, and ties, but I am going to have a reset. So I created a reset method that's going to reset my wins, losses, and ties to 0. Then I created getters for wins, losses, and ties. The next thing I want to do is I want to create some method that is going to validate the entry. So this is going to be able to be used by my interface to determine if the integer that was entered is within range of the rock, paper, scissors. And here's my method that I'm going to have in order to validate an option. So this method is going to get invoked. An integer is going to be passed in. I'm going to check to see if it equals to a rock, a paper, or scissors. If it doesn't, this is going to return false. So this is going to let the interface know the entry that was entered is not a valid entry. Now it's going to be up to the interface to use this method to check for a valid entry, because the next method I'm going to create is a method that's going to determine which player won. So this is going to be an interesting method. This method is going to take in two values, a value for player 1 and a value for player 2. It's going to do the comparison and it's going to return an integer to determine who won. Now what I'm going to do is I'm going to go with a positive number if player 1 won, a 0 if it was a tie, and a negative if player 1 lost. So here's a method I created. So I'm taking in two values. I'm taking in a value for player 1 and a value for player 2. In the case of the book, player 2 is going to be the computer. So I'm checking to see if the two values are equal. If they are, then I'm going to increment ties, return to 0. Then I'm going to check to see if player 1 won. So I'm going to check the value is equal to the value of player 2 plus 1 divided by 3. If it equals that value, then I know that player 1 won. Now I explained the logic behind this in my Java 1 class when I did this demo. But the way to think about it is it's basically just one circle, one cycle. So I'm going from 0, 1, 2, 0, 1, 2. So if I add 1 to this and I divide by 3, the remainder of that is going to be equal to this if player 1 won. Alright, so that's pretty much it for the blueprint class for our rock, paper, scissors game. So we can go ahead and put this into our driver class over here. So I'm going to go ahead and do that. So the first thing we want to do is we want to instantiate an instance of a rock, paper, scissors game. So now that I have an instance of a rock, paper, scissors game, I can go ahead and use it within my interface. So one thing I can do is I can change the logic in here. And here's how I change the logic for my check. I'm checking to see if what the user entered is not -1 and it's not a valid option. So if it's not a valid option or if it's not -1, then I'm going to go ahead and tell them they entered an invalid choice. I'm going to keep them in here until this becomes valid. Then the next thing I do is I keep this check here. This is still going to determine if I'm going into the logic of my game. Then I'm going to tell them what they chose. Then I need to go ahead and update my getItem call. I need to call this method through my object or through the class name. Because it is static, I can invoke this through the class name. But I'm going to go ahead and invoke it through the object name. So now what I want to do is I want to change this if condition to utilize what I did from my rock, paper, scissors game. Here's a method that I created, determine winner. This is going to return an integer, 0, 1, or -1. So I'm going to go ahead and capture this integer, but invoke this method and pass in my values. So I created a new variable called result. It's going to capture the result of this method, and whatever values inside of this result variable is going to determine what happened and whether it was a tie, a win, or a loss. So if result is 0, it's a tie. If result is greater than 0, it's a win, and anything else would be a loss. Now instead of using these variables, I need to go ahead and invoke the getters for my wins, my losses, and my ties. And that's it. So now we've written this in an object-oriented approach to where our interface is separate from our actual game logic. And this program should work exactly the way it did before. So let's go ahead and test it. So enter 1 for rock, 2 for paper, 3 for scissors, or 0 to quit. I'm going to quit. And the game's over. It gave me my wins, my losses, and ties. I'm going to run it again. I'm going to enter 1 for rock. I beat the computer. The computer chose scissors. I'm going to enter 1 for rock again. I won again. Now this time I entered in a rock and the computer chose a rock, so it was a tie. This time I entered in a rock and the computer chose a paper, so I lost. So I'm going to go ahead and enter 0 so I can get the results. And you can see I won 4 times. You didn't see all of them because I edited this video to where it didn't take so much time. I lost once and I tied 3 times. So this is the approach that I want you to take in your review homework part 3. Separate out the game logic from the interface to the user. So I went ahead and created a project template for the review part 3 project that I assigned, the pig game. So in this project, I went ahead and brought in the die class. This is the die class I wrote for my Java 1 class. All the methods and data are present, so this actually works. And here's a pair of dice class that I wrote for my Java 1 class. Now I did go ahead and finish this. This wasn't finished before, but I went ahead and finished it off. So everything that you need is in here. So you should actually use the one that you created in your review part 2 Java homework, but you can use mine, it's fine. This is the pig game. So this is going to be where we handle all the game logic. So this is going to be the blueprint class. Now I did say make the pig game for 2 players. In the book, 1 player is going to be the user, the other player is going to be the computer. So you can do this either way you want. You can either build in the logic of the computer in here, or you can keep it separated out. This is the class that's going to have to instantiate the dice object. So here you can see I have a pair of dice, and in my constructor is where I instantiate it. And this is your driver class. The driver class is going to be the interface between the user and the game. So this driver class is going to need a scanner. So you're going to have to instantiate your scanner object. And it needs an instance of the pig game. So you instantiate your pig game object. And then after this line, on line 11, that's where you're going to go ahead and start setting up your loops and getting into the logic of interacting with the user and sending the correct data to the game. Now this game is using the pair of dice. So it's actually using a different class. We're using a pair of dice here. So that means we're going to use all these services here. And this pair of dice is using the services for the die class. So you don't have to worry about using the die class. The pair of dice is going to handle all that. So in the pig game, you're going to use these services that are provided by the pair of dice class. But that's pretty much it. I mean, it's all set up for you. So really, the first thing you need to do is interact with the user, get the data that you need, and then you can go ahead and start setting up your blueprint class for your pig game. I want you to just think about what you need. It shouldn't actually be too much. I mean, really all you're doing is keeping track of 2 scores, and then whichever one gets to 100 first is going to be the winner. But depending on what they roll is how much you're going to increment the score by. And each user, whether it's the user or the computer, they're going to decide if they want to take another turn.